Hey Opties! Today we're learning about I. I is what we call the imaginary unit. That's right, imaginary, like a ghost. And we're going to talk about how we get I and how that applies to square roots and operations with our imaginary unit. And so let's go ahead and look at square roots. I is defined as I squared equaling -1. So that's the definition. And based off of this definition, including this I, which is our imaginary unit, if we take the square root of both sides, we get I is equal to the square root of -1. And I know that when we take the square root, we usually have plus or minus. But for these purposes, we just have the square root of -1. So next, let's take a look at what complex numbers mean. Really, all this means is just numbers that have I in them. And they can be written as A plus BI. A and B are real numbers. And I is not a real number, it's an imaginary number. It's that imaginary unit. So there is a real part and an imaginary part. Now your real part could be 0, you could just have like 2I. But it could have a real part and an imaginary part. So this right here is how we would write complex numbers. Let's take a look at some examples. A says simplify the square root of -24. Okay, so we could rewrite the inside of the square root as -1 times 24. So we're rewriting that radicand. Remember, that's the word we use to talk about what's underneath the square root. So then we could separate to the square root of -1 times the square root of 24. So we know that the square root of -1 is I. I is the square root of -1. So this becomes an I, and then we still have the square root of 24. And we're not quite done because we do want to write our square root of 24 in simplest radical form. But here is the first step. And you don't have to go about rewriting this every time. If you see a negative underneath your radical, that means an I is going to be coming out on the outside of your radical, okay? So it's going to be I squared to 24, and if you had the square root of -100, it's going to be I squared of 100. If you had the square root of negative smiley face, it's going to be I square roots of smiley face. So the negative inside of the radical always goes away when you put an I with it on the outside of the square root. So let's finish real quick the simplest radical form of our square root of 24. So 24 could be 4 and 6. And 4 is 2 and 2. We know it's a perfect square. 6 is 2 and 3. So it can be, there's a 2 that comes out front because the square root of 2 squared is just 2. And then we still have 6 on the inside of the radical. So our final simplest form is 2I square roots of 6. So you always want to put your I kind of between your number part and your radical part if you still had some radical pieces. So put your I in between those two. B says solve, and we have 4x squared minus 16 equals 0. So since there is a B value of 0, which means there is no x term, we'll do solving by square roots. So we'll subtract 16 from both sides. We have 4x squared is equal to -16. Divide both sides by 4. That's a 1. And now x squared is equal to -4. And now that we have this, when we take the square root of both sides, we have x is equal to plus or minus the square root of -4. Well, we know that a negative inside of the radical becomes an I on the outside of the radical. And we know the square root of 4 is 2. So that's just plus or minus 2I for our final answer for B. Our point to ponder just kind of talks about the reasoning that we need anything such as the imaginary unit I. So the reason it's been created is because when you square any number, it has to be positive, because a negative times a negative is a positive, and of course a positive times a positive is a positive. So there's no way that you can square a number and get to a negative. Therefore, whenever you do like we did at the beginning and take the square root of both sides, you cannot get to a negative number underneath your radical for any real number that you're squaring. So that's why we had to create something to represent that situation, and that's why I was created as our imaginary unit. Next, let's look at some operations. So I have here a table that shows the first few powers of I, meaning you're taking I and you're putting some sort of exponent on it. So let's start with just I to the 0th power. And we know that anything to the 0th power is equal to 1. If we had I to the 1st power, that's just simply I, which then simplifies to I. If we start going more, we get to I squared. And remember, the definition is that I squared equals -1. So that equals -1. And based off of this definition is how we get the rest of our results. I cubed would be 3i's, which is the same thing as I squared times I. And we know I squared is -1. So then we have -1 times I, which is -I. So you see, as we keep going, we just have examples of I squareds and then whatever's left over, whether it be another I. So like for I to the 4th, we have I squared times I squared, which is 4 i's total. And that's going to be -1 times -1, which is 1. So if we look at our pattern here, we have 1, I, -1, I, 1, I, -1, I. And that is how it goes for all the powers of I. That is the pattern. So we see the pattern here. So it's pretty interesting that the powers of I do have this cool pattern. And we will definitely be using the I squared rule when we are multiplying. So once we multiply, we might get an I squared, and just remember that you always need to simplify that to -1. Don't leave it any I squareds. Notice that in this pattern, there are no powers of I other than 1. I could be negative, could be positive, or it could simplify to 1 or -1. So whenever you're done simplifying for multiplication, you should never have any I squareds, I cubes, or anything. It should just be a plus or minus I. Let's take a look at adding or subtracting. So we have this imaginary unit I, which makes complex numbers. And when we add and subtract, it's really just treating it as an X, is the way you can think about it. It's like you're combining like terms. So let's take a look at example A. 5 plus 3i plus -2 minus 4i. Now, we didn't actually super need these parentheses, but these parentheses do help us see the two different complex numbers. For our first complex number, 5 is our real part, and 3i is our imaginary part. Then we have -2 is our real part, and -4i as our imaginary part. So we're just going to combine our real parts together and combine our imaginary parts together. So 5 plus -2, that's how we're going to combine those real parts, and that's going to be a 3. And then 3i plus -4i is going to be 3i minus 4i, of course, and that's -i. And that's all you do. And I like to make my eyes like this little swirly looking eye, kind of like we had up top, or where it has powers of I. For example B, very similar, we're just subtracting. So we're going to combine our real parts. 8 minus 2, it's just a 6. And then -2i minus 6i. Let's write that. I don't want us to not distribute our negative, which means that negative is going to go on that 6i. So don't forget that you're subtracting that 6i. So it's going to be 6 minus 8i. And that's it. Finally, let's multiply, distribute, and then don't forget to simplify powers of I. So that's our rules. So if we have I squared, it becomes -1. So we're going to distribute. So 5 times -2 is going to be -10. 5 times -4i is -20i. So just like if you had an x, 5 times -4x is going to be -20x. If it's an I, it's going to have the I there. Then we've got 3i times -2 is a -6i. And here we're going to have I times I, so it's going to be I squared, and then we'll simplify to -1. 3i times -4i is going to be -12i squared. Okay, so we've got -10, And then negative 20 minus 6i is negative 26i. So that's like combining x terms, but they're i's, right? So we're still thinking about kind of like the like terms. We had to do a little bit of subtraction there, just like we did on example B over here. And then our negative 12i squared, the I squared becomes a negative 1. And now this is just a constant, it's just a number. It's a positive 12. So finally, we'll have the negative 10 plus our 12, right? So that's going to be 2. And then we have minus 26i. And notice I put the real part in front. We're using that a plus bi form. Finally, example B, I thought I'd throw in just one binomial squared for us not to forget that this is the same thing as 2 minus 6i times another 2 minus 6i. This is not the same as doing 2 squared minus 6i squared. You can't just distribute your squared there. When you square something, it means you're taking that thing and you're multiplying it by itself twice, okay? So it's 2 of those things. So let's practice now doing our distribution again. 2 times 2 is 4. 2 times negative 6 is 2 times negative 6i is negative 12i. 2 times negative 6i again is negative 12i. And then negative 6i times negative 6i is positive 36i squared. Okay, so simplifying, we've got 2 negative 12i's, so it's going to be negative 24i. And then our I squared becomes a negative 1. So that's going to be a negative 36 as our constant for our last term here. So then we've got the 4 minus the 36. And so our real part is going to be negative 32. And then we have negative 24i. So writing that real part first and then your imaginary part. So let's just clarify that A is going to be negative 32, just if we're thinking about A plus BI. And then B would be negative 24i. All right, Opties, that's it for complex numbers with our imaginary unit I, including square roots and operations. See you next time.